Okay, in the last video, I talked a little bit about, well, we basically gave you an introduction to Cartesian products and how they work. Mentioned that maybe on an exam you could see a problem that is asking you to find the intersection of two Cartesian products, which actually is really easy if you're familiar with Cartesian products and you understand intersections. And I'm going to explain to you why that is. So first off, we're going to start by working the problem the same way that you would work any other problem involving finding the intersection of two different sets. You're going to identify all the elements in each of the different sets. So we need to identify all the elements of A times B and identify all the elements of B times A. To do that, I'm going to use tables because I think it's probably the clearest, easiest way to visualize Cartesian products, and it basically eliminates any chance of you accidentally leaving out an element, because you'll just definitely notice as long as you set your table up the right way. So let's go ahead and set that table up. And to do that, we're going to take it, since it's A times B, we're going to make A where the rows would be in this table. So we'll take all the elements from A and put them here. X, Y, and Z. And then we'll take all the elements from B and put them on top where the columns would be. And that'll be B, X, and Y. And draw our table. That's going to be a tight fit, but anyway, we'll start drawing our ordered pairs, X and B, X and X, X and Y. And remember that, and since you're getting the cross product of A times B, the first element in the ordered pair is always going to be an A element. In this case, there's some shared elements, so it'll look like that's an element from B, but really that's A's X, not B's X. And we'll go on down. Go ahead and finish out our table. Oops, that's supposed to be an X. Okay, now that's the Cartesian product of A times B. Now we'll go over here and we'll go ahead and create a table for B times A. And let's put all our elements from B on the left side here. B, X, and Y. And then all our elements from A will go on top, X, Y, and Z. And then we'll create our ordered pairs. BX, BY, BZ, okay, and realize that even though there are kind of individual elements within this ordered pair, when we're talking about Cartesian products, the ordered pair itself is the element. These aren't individual elements within this ordered pair. This is its own unique element, BX. So keep in mind that BX is not the same thing as XB. That's not the same element. It's an ordered pair, so I mean order does matter in this ordered pair. So we can, right off the bat, we can easily eliminate certain things just by saying that, okay, B is not a shared element between sets A and set B. So obviously the ordered pair can't have the same ordered pair for the cross product of A times B and B times A, because B is not a shared element among them. So you can go ahead and just eliminate anything involving B. I'm just going to do that here by crossing these out. And we can also see that Z is not an element of B, so obviously we can't end up with an ordered pair that is the same for A times B and B times A when B has no element Z. So you can go through and just eliminate anything involving Z. And so that leaves you with only 4 elements, which are all shared elements. You can see obviously XX and YY are the most obvious, but you have XY and YX, but you're also going to have that here too, because they're shared elements. So then you have these 4 elements. And then your solution here is going to be xx, xy, yx, and yy. And that is the intersection of these two Cartesian products. And looking back, you can tell that why I said this problem was easy. All you really have to do when you see a problem like this is identify, okay, what elements are shared, and okay, they're obviously going to be xx, yy, but they're also going to have xy and yx. Like, you can take them and flip-flop them, and you know that that's how it's going to end up. And the more of these you do, the easier that'll get. Just like a lot of these problems, just the more you practice, this kind of material, just not specifically Cartesian products maybe, but in this class you're going to have to practice a lot of these problems a lot of different times.